So today I'd like to talk about how to use definite integrals not to find the net area between a function and the x-axis, but to find the area between one function and another function. So consider the scenario that we have two functions called f of x and g of x. And we're going to assume that f of x is the larger of the two functions, that f of x is greater than or equal to g of x on whatever interval a, b that we're interested in. How can we then find the area of the region between f of x and g of x? And just to give you an idea of what's going on, let's get a little sketch going on the right-hand side. We have a function f of x who is above g of x on an interval a to b, and we're interested in finding the area of the region trapped between these two functions. This can also be found using a definite integral from a lower limit of a to an upper limit of b. But this time, instead of integrating just f of x, we're going to integrate the difference between f of x and g of x. We're going to find the integral of f of x minus g of x. Now let's try and use this formula on the following exercise. Find the area of the bounded region between y equals x and y equals x squared. Now when you're doing these problems, I always recommend starting by getting a graph of these functions listed here. We have y equals x, straight linear function, identity function, y equals x, and then we have the quadratic function y equals x squared, y equals x squared. And the area of the bounded region between these two, the region that's not infinite, the region that's finite, will be this area shaded in red here. Now the first thing that I'm noticing is that on this bounded region, the top function, the one that is on the higher end of the region, is the linear function y equals x. So if I'm going to find the area between these two functions, I should put the top function of x in the lead, and the bottom function of x squared should be subtracted. But now the question arises, what will be the limits of integration here? In other words, what are the x values that form the boundary of this region? Now I think the graph reveals that the left-hand boundary of this shaded region is x equals 0. To find the right-hand boundary, I'm going to go ahead and set x squared equal to x to reflect the fact that these two functions are intersecting at this point. Now, as we can see, this equation holds true for x equals 0, indeed, but this equation also is true for x equals 1, since 1 squared is equal to 1 again. So I will integrate this function from 0 to 1 to get the integral over this red region. Finding my favorite antiderivative using the power rule. X squared over 2 minus x cubed over 3. We can then plug in the lower limit and the upper limit and take the difference of the two results. Since plugging in 0 to this antiderivative gives me nothing, I'll plug in 1 squared over 2, take away 1 cubed over 3, and this 1/2 minus 1/3, this 1/6, would be my final answer for this example.